Good morning and happy solstice, everybody, and welcome. I'm here with Milton and Keith Wazalewski, and we are here to talk about the summer solstice, the winter solstice, the June solstice, I guess. So we are getting started right on top of the hour, right on time. So welcome, everyone. I'm going to hand things over to Keith, who is going to give us a little bit of an introduction of what is so special about today and what is happening.
Yeah, I didn't realize I was muted. Yes, we are. This is the day, the big event, right? The June solstice for 2023. Depending on where you live, it will have a different significance. For us in the Northern Hemisphere, it is the official beginning of summer, the longest day of the year, right? Not the longest day of the year. Days don't change. Days are all the same length of time. It's just we have the most sunlight for the days of the year. And we have Milton with us today, who's in the Southern Hemisphere, where it is the beginning of winter. Milton, welcome.
Thank you very much. Yes, it's nice to be back in the Southern Hemisphere. And of course, here we're celebrating the winter solstice, as most people say it, and again, our winter is not as harsh as the Northern Hemispheres because of the tilt of the Earth, but it's still a wonderful time to take a look at the skies.
We are going to go over all that, but before we do, Mr. Paul Cox is on the solar telescope. Let's take a quick look at the sun. The sun has been really good today. Wow, we have all these prominences on the limb of the sun. When it comes time to the actual moment of the solstice itself, because the solstice is one of those specific time events, kind of like a full moon. The moment of solstice, we see two different times. I'm seeing 1451 UTC on the event page. Gretchen was seeing 1457. So we're going to take pictures at both of those times for the exact moment of the solstice when the sun is at its highest point in the sky. For those of us in the Northern Hemisphere, highest part in the Southern Hemisphere for the lowest area. That's not really making sense, is it? We're going to take pictures of both moments of solstice. Okay, so Paul just changed the exposure. We're seeing some different things. We're in more of an H alpha filter, seeing some of the plasma of the sun. We're going to hop back and forth and toggle between some of these sun images as the day goes on. But let's get right into it and talk about what is happening today. So when we think of the word solstice, it's a combination word, a prefix and a suffix. So sol, whenever we see sol, that is the Latin term for sun. So when we think of solar system, again, it relates to the sun. And the second part of that is sistetic, which is a second conjugation Latin verb, in case you were keeping such things. It's in the infinitive, and it means to stand still. So this was something that was understood, that to stand still or would appear to rise and set in the same location. Now, this is a kind of an artist's rendition of a very famous monument. We're at Stonehenge, where during the solstice, the sun does appear to rise from this break in the rocks, right? It was designed and built this way. And if you change position, the sun would appear to set in the other part of the sky as it rises in the east and sets in the west. Ancients understood that that location was actually the same. And it's not just the same on the solstice. Usually you can get a day or two before and a day or two after where it's in that same general position. So the Druids were not the only group of people to do this. We have monuments all across the world where many, many peoples have tracked the movement of the sun rising where it does in the east at that same spot during this particular time of year and setting in the west at that same particular spot. And Milton is going to show us some examples in Mesoamerica. But it's something that, if you go on YouTube, there are examples all over the world. As I mentioned, this was a known phenomenon. There are some more technical things that happen during the solstice too. Depending on how much time we have, I may want to go into stellarium because there is a relationship between the sun and where it is in the sky. I don't know if we're going to do that right away. So I want to talk about this diagram. We have to imagine this is a Slooh approved image that I took from one of the other solstice star parties. So we have to imagine the sun being over here. Now the Earth is at a tilt of 23.5 degrees. So if we take a line, this is the north celestial pole, it's tilted at that rate. And as the Earth makes its orbit around the sun, different parts of the Earth are closer to the sun and other parts are further away from it. So for us in the northern hemisphere, this is the closest point that we will be at the sun, and that marks the beginning of the summer. In the southern hemisphere, where Milton is, and I saw some other southern hemisphere guests here, that part of the Earth is further away from the sun. So that is wintertime. Up here, it is summertime. In the northern hemisphere, this diagram doesn't show lines for our tropics. So the Tropic of Cancer, if you imagine a line parallel to the equator, would meet up with this path to the sun, the plane of the orbit, the plane really of the ecliptic, and the sun will be directly overhead at the Tropic of Cancer. At the North Pole, the sun doesn't set. And if you go through some simulations in a program like Stellarium, you will see that as the sun makes its way across the sky, it just barely skims beneath the surface of the horizon. It doesn't really set. And that's if you're in the Arctic Circle. So it's a very, very interesting phenomenon to have this thing going on where the sun doesn't set the time of the midnight sun, right? Southern hemisphere, Antarctica, complete opposite. The sun never really rises. It just kind of skims beneath the horizon, and we don't really have daylight. Kind of a depressing thought, but that's what's going on today. We are at the summer solstice in the northern hemisphere. Milton is having winter down there. How does it differ from some other events that we have? Well, the equinox is when we have equal day times in the northern and southern hemisphere. And then as we move into wintertime, the roles are reversed. We enter into winter and the southern hemisphere enters into summer. So why don't we take a break? Milton, why don't you fill us in on what's happening? Like I said, we're moving into summer. Our days after today will actually start to get shorter as we approach the equinox, which, is quite a while away. The autumnal equinox when we have this position, and then we'll move into the winter solstice where the days will start to get longer. But our days after today are actually going to start to get shorter, but you're in the opposite situation. So fill us in on what's happening down south.
Of course, really love your diagram because it absolutely shows that difference. The Earth is now getting closer to the sun, but although it's winter in the southern hemisphere, because of that proximity, the winter is never too harsh. We don't have snow unless it's in the very high mountains and maybe during the morning in some altitudes. But for most part, it's still a mild winter. And it still marks the beginning of a new year for the natives in Bolivia. We are counting now 5,531 years following a lunar calendar. And, for them, it is the beginning of a new year. And that's contagious. Everybody feels that way. It's a holiday today. So Happy New Year. Happy, Andean New Year for all our listeners and watchers in the world.
Yeah, that's great. Now, Milton, you also had mentioned that there's a relationship with Venus and the New Year also. I know that's not related to the solstice, but kind of an interesting fact.
Oh, well, yes. You know, in Bolivia, we have very different cultures, and although most of us will follow the traditional calendar, let's say, our natives have their own that has been on since the times of the Inca, for example, and so they still keep track of that. And because of the belief of a lunar cycle, let's say, they keep counting in this 28 day months, let's say, that eventually add up to almost 364, you know, if you do the math, leaving today as that special day of the year in which we reset. This is the moment we stop everything, as the title of our webinar now shows, and we reset our lives. It's the time of you know, thinking about what we did or what we're going to do in the next year, let's say. So it's an interesting feeling that we have around here.
Yeah, that's great. You know, it's so nice to be able to compare between the two. You know, here, you know, as I said, we're just beginning summer, but we're already looking forward towards the fall, towards autumn, because the days are going to start to get shorter. What does that mean for us here on Slooh? That means we get more telescope time. The telescopes will go online earlier and earlier. We're at the time now going through summer astronomy camp, and we're like right at the time of telescopes come on. We're right at 5 o'clock. So talking about telescopes, we're getting some great solar images here that we've got to take a look at before we go any further. Wow. So we've got this incredible prominence on the limb of the sun, this explosion of magma and plasma and just solar material. Oh, really changed the exposure. Now we're seeing kind of the surface of the sun. We see some granulation. You see these bright areas. That's a plage. Usually these are in the vicinity of active regions. So we can kind of see this dot here, an active region, and then this brighter area. We're going back to this beautiful prominence. Ooh, this is great. You can see that it kind of blows from the surface of the sun and then gets sucked back in through magnetism. This is really great. An arched image. This is where you want to start taking pictures. We are going to take pictures at the exact moment of the solstice, but this is pretty good for solar observers. I'm going to keep an eye on this.
I noticed that we've got Jenny and Mac here.
Yeah, do you want to walk us through what's happening here?
Yeah. Hey, Mac or Jenny, would you like to come on and talk a little bit about these features that we're looking at in the?
I'll leave the sun up and you can fill it in.
Hi there. This is Mac.
Hey, Mac.
Can you hear me now?
Yeah, we can hear you.
So we've been watching this. The upper right, upper left quadrant is called the northeast quadrant of the sun because east is left and west is right. So on the northeast quadrant, this large, very long prominence, limb prominence, has been going for 2 or 3 days. And it appears at the moment that it's ready to erupt into a coronal mass ejection. So newsflash, this might actually be a spectacular ejection of protons and ions, helium, simultaneously as a magnetic ejection from the surface of the sun. So that's going to keep us busy looking at this for the next few hours as we follow its path with various telescopes, including the solar telescope in Canary 5, which will continue for a couple more hours. And then we use space satellite telescopes and other ground-based telescopes to follow the progress of this prominence. So exciting times.
Yeah, Jenny, do you have anything to add about what we're looking at here?
Not for this image. I've been watching these for several hours, just trying to see what we're going to be working with today. And it's been a pretty superb viewing day. Good conditions and spectacular activity on the sun.
So the sun did not disappoint us on the solstice, right? Awesome. Oh,
Yeah, I
and
took a
changing
quick view
colors.
earlier.
What's happening here?
So this telescope is a fairly small telescope as apertures go, but it has a lot of little gizmos inside the solar telescope to change the fine tuning of the H alpha band that's passed through the telescope that we can see. So in one form of tuning, which is controlled by a pressure valve, this current image focuses on the chromosphere, which is a little bit higher up above the sunspot surface, and we see more H alpha played bright lines and squiggles, and those are magnetically active plasma zones. So this is focusing on an area of the sun that's about 100 to 1,000 kilometers above the surface. Whereas the other tuning, where you see the bright ball and the edge prominences, is just a very minute change in pressure inside the solar telescope, which has a technical term I can't remember. But it's a controlled angling of the internal lenses of the telescope that create this effect. Same light, different perspectives on the same information on the light.
Super.
Yeah,
cool.
one of the interesting things here that I see, when we saw that beautiful prominence on the limb, as the sun rotates, they become these filaments that we see. So as the sun rotates on its own axis, these will become prominences that we'll notice on the limb. So great sun today. Like I said, I took a look at this myself earlier today. We have a question. Let's see what we have. I believe you're referring, I can't. Okay, the Edelon cavity. Mac, do you know anything about that?
Yeah, Roy has a question or making a comment. I believe you're referring to the Edelon cavity. So Mac, can you speak to that? Are you familiar?
I haven't held one of these telescopes in my hands ever, so yes, the Edelon cavity is a internal optical cavity between two sets of lenses, and the pressure of that cavity changes their orientation relative to one another. Technically, it's called the Edelon.
Okay,
I wish I had
nice to
one
see
in my hand.
Mr. Paul Cox, our executive producer, who's working the Slooh telescopes today. I see has turned his camera on, so that is a pretty good indicator that he wants to talk to us. Paul, take it away.
Yeah, I just wanted to say a little bit about, it would be great if we can stick to the view of the solar scope while we're looking at this.
Okay, I'm sorry.
So the solar telescope, as Max said, it's one of Slooh's smallest telescopes, but brightest object in the sky. We don't need a giant telescope to collect loads of light. Actually, the challenge here is reducing the amount of sunlight that hits the camera. So Mac was right in this. There are actually two filters in this special little telescope. One is at the front, and they have a tilt mechanism. And all of these filters, solar filters, work in the same kind of way. It's normally two optical elements. So in this case, two pieces of glass which have been coated with special coatings to reduce the amount of light that comes through. But then what happens is the internal reflections of those two, or the internal surfaces of those two optical elements are very highly reflective. So actually what happens is the light wave bounces back between them, and it starts diminishing the amount of light further. Then it goes back to this special, very special filter that Mac was talking about then, which is actually located halfway down the telescope. And this is called the etalon. And this, once again, is two pieces of glass, but instead of tilting like the front one, and what the problem is, when we tilt like that, it actually changes the optical path. And we often get, you'll often see it in the view, we saw it, I think, right at the beginning, a secondary reflection of the sun because of that front tilt mechanism. Well, the Etalon inside, as Mac hinted at, works in a slightly different way. The two optical elements, two pieces of glass basically, are fixed in position relative to each other. But what we have is we have a little air pump, and at the moment I can tell you what that's set to. It pumps air in between those two pieces of glass. At the moment I've detuned the telescope, so it's only got 1 psi, so it's virtually not showing us H alpha wavelength at all. We're actually now looking at the photosphere. That's why we can see very clearly those sunspots. So I'm going to turn this up while I talk about it, so there'll be a little bit of a delay. But what's actually happening when I'm increasing the pressure, I'm going to increase it to about 13 pounds per square inch. So that's quite a lot of pressure in between these two pieces of glass. And what that does is, I used to get this wrong. My initial understanding of how these Etalons worked was incorrect. I was originally told that that pressure increases, kind of bloats out the glass, pushes it out in the center, and changes the distance between them. Well, that's not actually right. What really happens is the pressure of the air inside changes the refractive nature of the air between the two, and that's what's actually changing. It's kind of almost, it doesn't really slow it down, but it's the equivalent of that. So it changes the properties of the light as it's going through there until we get this, which is our hydrogen alpha view. So hydrogen alpha, this is excited hydrogen particles in the chromosphere. When we say excited, they've been energized up to another energy level, and when they fall back, they release photons, and those photons are at the H alpha wavelength. That's why we call it the hydrogen alpha wavelength. And if you go to the telescope guide page, it'll tell you everything you need to know about how that's kind of measured. So we're looking at 0.5 angstrom and things like that. But this is where we see. So we've just basically, Mac I think talked about the chromosphere's thickness, you know, of slightly over 1,000 miles or something like that. What we've just done there is we tuned the telescope so we were looking at the bottom, we were looking at the photosphere, which is kind of the layer that we see if you put a pair of eclipse glasses on. That's what you see. If you see a sunset, that's the layer that you're seeing. But when I tuned the telescope, increased the pressure, we basically traveled up through the solar layers and through the chromosphere. And that's why, as we change it, different features come in and out of view. So just thought that'd be interesting. I think we should probably go back to that prominence. So I'll shut up and reposition the telescope and tune it so that it's just perfect for that prominence. Now, what you may notice when I do this is one part of this prominence is going to be so bright it's going to be overexposed. But that's so that we can pick up the very faint part of it down below. And it's quite problematic. It's quite difficult actually sometimes tuning the telescope so you don't get overexposed areas and then miss some of the fainter detail, and vice versa. So anyway, back to you.
Thank you, Paul. I really appreciate that walkthrough and explanation. It was like very helpful, very exciting. Keith, what is next?
I thought we would take a look at another one of these graphics that shows just what's happening when the sun is doing its thing. So this was another graphic. So we look at the position of the sun in the sky. So this first image here shows the solstice at 40 degrees latitude, which is very handy. That's about where I am. I think I'm 41 degrees. So the sun will rise in this eastern portion of the sky. We'll reach a high point in the sky, and that's what happens during the solstice in the northern hemisphere. This will be the highest point in the sky that the sun is going to appear, and then it'll set in this spot in the west. it's very similar to other astronomical events like the midnight culmination. Somebody in astronomical camp that we're having asked about, they couldn't finish their midnight culmination, the Pleiades thing. News break to the scopes. We've got to go back to telescopes. Let's take a look. Something must be going on here. Oh, I can see why. Wow. Huge prominence here on this eastern limb, northeastern limb of the sun. Mac, what's going on here? Oh, we're getting a nice zoomed in shot. Wow. You can see how it's starting to arc and drifting off into space.
Yeah, the arch is expanding. I think we're going to have a bona fide coronal mass ejection within a couple hours, maybe.
I think that's very
One of-
obvious.
One of the
how,
addictive features.
yeah, how much that's grown since we last saw it. Mac,
Yeah.
you know, we normally have the little Earth symbol on there to kind of put these things into scale. We don't have that on the scaled in view, but my estimate would be that little patch that Keith talked about there, kind of pointed to, that kind of void. I reckon you could probably fit around 5, 6, maybe 7 Earths in there. I mean, these things
That's right.
are gargantuan, aren't they?
And getting bigger. I've been looking at that for a couple of days. What do you think, Jenny? We're going to have a CME out of this?
I'm always optimistic.
That's great. Me too.
That's why we get addicted to watching this solar telescope. There's never a dull moment,
Well, can
really,
you, like,
during
add a
this
little bit
solar
more?
cycle.
Add a little bit more about like the CME and like why is this like, oh, wait for the CME?
CME is a
tell us.
coronal mass ejection, when what you're seeing on the prominence actually exits the sun instead of staying magnetically attracted. Like you're seeing here, you're seeing a lot of the loops, and I like to think of them as waves back and forth as the positive and negative aspects of the magnetics from the plasma take action. I don't do the scientific explanations, I just try to describe what I see. But you'll see stuff that hangs out there way beyond and erupts. I believe most of you have seen and observed Canary 5 when it's really got the really long streamers going up and out of plasma, and then they just separate completely off. And then of course there's all of the solar dynamic observatory and other solar observatory places that have some really dramatic images and video clips. That's what we're talking about. They erupt off from the sun and they move on out to space. And depending on how the sun's facing Earth, it may bypass us and we won't see any effects here on Earth. I think there's been a number where they've mentioned that it's ultimately crossed into one of the other planets that ended up in the path. And so there's a lot of scientific information about what can happen on Earth here. They tend to cause disruptions in radio frequencies, which we've seen the last few days, several examples of that. And they can disrupt other kinds of electronic systems and spacecraft and so forth. Any other thoughts, Mac?
Yeah, the effects of solar coronal mass ejections are pretty amazing. One of the things that happens during the solar cycle, which Keith and others can probably address a little bit more, we're near the first maximum of this solar cycle 25, which is an 11-year cycle, and it's kind of bimodal in shape. So you get this 2 peaks of solar activity in terms of numbers of sunspots on the face of the sun. But anyway, right now we're at about the first peak of solar maximal activity in this solar cycle. And what happens during this time is that there's so much radiation pressure on the on the Earth's atmosphere and magnetosphere is that the atmosphere will actually expand a little bit. It heats it up, the upper atmosphere, and it can produce drag on satellites. And in the case of Elon Musk's space company, SpaceX, he's firing up satellites at a very high rates, 50 or 60 a month or more. And some of them don't make it because the Earth at a given moment has this upper atmosphere expanded and they get dragged back into Earth. So he's lost several dozen satellites in the process of trying to get them into a stable above the low Earth orbit, and because of solar activity causing drag on his satellites. So they need to really pay attention when they launch these things to the current state of the Earth's atmosphere, upper atmosphere, caused by solar particle injection into it.
Wow, that's a lot.
Yeah.
Well, thanks for sharing. Oh, yeah, we're moving again. We're moving. Now we get to
There's
see another feature.
a promenade of prominences that we're seeing.
Yeah, exactly. Promenade of prominences. So we're at the bottom of the hour, so let's take a quick breather here. If anybody has any questions or comments, we're kind of in a very privileged vantage position here to be able to look at all the scientific data that we have available to us. But we have to remember that the solstice for so many people across time has really been a natural phenomenon and has a spiritual connotation. So if we don't have any questions, Milton, I want to turn this over to you so we can talk about the ways that other cultures through time have celebrated this incredible event, knowing that if we get a news alert, we're going to have to break back to the solar scopes. Fair enough?
That sounds pretty good.
Okay.
Okay, now we're back on. I'm gonna be giving you a little bit of a tour around those ancient cultures that you mentioned. This I will do by taking everybody with me down the tunnel of time. And if you follow me, we're gonna land first in the land of the Maya, who traditionally have been looking at their portion of sky, and of course based the whole culture on what the sun did. They were the ones who called the sun the giver of life, and they observed it without the wonder of our telescopes, but by noticing how the sun would affect their conception of even the constructions. What you see here is the Temple of the Sun in Palenque, and if we went down the tunnel of time, this is what we would probably see. These billboards that we can call today were made of stucco, so they didn't last the test of time. But modern technology allows us to more or less, see what they depicted, and this one depicts the sun god that they could see if you see this map, from all the angles. Now we have to keep into account that the Maya did not have really clear skies. Most of their sky was covered by the canopy of trees that they had, and except in bigger cities like this one, most of the trees were done. But the sun would come out, let's say, below the canopy of the trees, so they had to make observations almost at ground level. Here you have, for example, the different angles the sun will take during the year. And, since they were mostly in the summer solstice now, that's the top angle that you see in the image. Now, this is a picture, an actual picture of what happens. The trees block the sun for a lot of time of the day. But as soon as it comes in, it will go into the chamber that you see in this sun observatory for them. And you see the angle of the sun, which will, at this point, hit that right corner. where they had hand painting that reflected, that time of the year. In the solstice, the sun will go straight all the way into the back chamber, with the particular effect it has in the population. And of course, in their summer solstice, the sun will hit the other column. That's what they tried to do with all of their constructions, including the Chichen Itza, constructions. All of them were oriented to the sun. It shows a real deep worship of the sun, which they passed on to the Aztecs. This is a sample of Aztec tapestry, and one of the most incredible ways in which culture passes on from conquered to conqueror. In this case, the Aztecs were the people who were expanding in that period of time, and since the Maya had arrived in a moment of declination, it was very easy to take over those constructions by the Aztec, and they brought with them the calendars, the concept of the calendar. This to us is just a very everyday concept, but for them, being able to kind of predict things, because of a calendar, was one of the biggest discoveries. In the center of this sunstone, we see this. This would be the kind of view that you would have in those days, with all these ochre colors painted on the surface of the stone. And in the middle, you see Tonatiuh, their conception of our sun. Tonatiuh was a little crazy. It was a crazy divinity. It is the giver of life, but it's also the killer. And so they understood the importance of worship to the sun because of that. It was a very thin line, that divided this very benefactor god and this killer god. And so they understood that. Around the sun, you see the calendar that I meant, the 20-day cycle over here. And of course, times of planting, times of plucking, everything was calendarized around this stone. This stone right now is set on the wall of the National Museum of Anthropology in Mexico City. But during those days, this would be like a table, a round table, around which the experts in reading this calendar would gather around, and they would predict most of the things that were going around their lives. Probably the most interesting and incredible prediction is that the Earth will one day, have another mass extinction because of volcanic activity. We were thinking this was going to happen in 2012, but lucky for us, we are still here, and we are just waiting for that to happen. Well, these people existed quite a long time ago. I think we can give them a little bit of lenience and probably have the time to get ready for any inconvenience of our volcanoes. Now, moving down to the southern hemisphere where I am right now, I have to really iterate the date I gave you. The year now around this area is the 5,531 that they followed by observation of the sun. Also, the god on the top of this gate, the sun gate in Tiahuanaco, would look like that in the time the Inca saw it. And of course, they adopted the sun god into their own culture as well. Now, what went on in Bolivia just a few hours ago when the sun came out is this. In our winter solstice, the sun will come into the realm through this gate. And this was the moment, the exact moment the sun came up over the hills through the gate, and people were celebrating the sun's visit with palms that they would extend towards the sun, trying to soak up all that energy, the energy that the sun will brings every day. But today is special because of the moment we're living. Even to our ancestors, we knew that today the sun stands still, and that's the moment where more of that energy comes our way. But I'll take this opportunity to also talk a little bit about another celestial object there. It's our planet Venus. If you're very careful, you will see Venus right there. I'll try to. Yeah, I zoomed Venus a little bit so you can have a better look, because Venus today, for example, stays longer in the sky after the dawn. Most of the stars are now gone, but Venus is still that morning star that our ancestors in the Amazon would look at, and that also for them was a very special moment in their calendar. Both the Amazon and the Andes are celebrating today the 531st year of their lunar cycle. Well, with this other alignment that I see you, as I show you, I want to basically wrap up over here. And of course, ready for any questions you might have about the ancient cultures of Meso and South America.
Yeah, Milton, we're going to take a look at the telescope again in a little bit, but I want to go back to what you were talking about with the sun standing still. We have all of this scientific equipment today, and there is a reason, because the sun really does stand still. When I was talking about the sun being at the highest point in the sky, we don't have a very steep curve of the path that it follows, the ecliptic. It's kind of flat. It flattens out. And we see this especially in the wintertime, when the Pleiades will be very high at its highest point, more or less for several weeks. The ancient people understood this by these stones and temples and monuments they have built. Can you maybe share with us how they were able to observe this phenomenon without the benefit of the equipment that we have today?
Yes, according to what I found out, the process of building these structures around what you just mentioned is incredible. I mean, it requires a lot of observation and maybe many, many cycles, one after the other, before they can actually, figure out what is going on and then build around it. They are, of course, not the only culture that did that. You show the Stonehenge, for example, and all around the world we have all these orientations towards the sun. But it really required lots of observation, lots of marking, the territory, and then conceiving the whole structure around those observations. It's something we don't do today. Most of the time, we have become, for example, a culture that follows the north, south, east, and west, arrangement, and we build around that. But we forget that our planet does not have a true spherical shape, let's say, and that if we want the best constructions, we first have to look around and then build around it, right? So it's a different concept of what the builders in those days would do with their structures.
Yeah, and you have to imagine, as you said, this happening over a period of many, many years. I was looking at some videos on YouTube of some 5,000-year-old stones in Ireland, and there was a real practical application to this, whether or not a religious festival or connotation or meaning was associated. That occurred much later. There were real practical reasons for this because of crops. It had an agrarian function. Thoughts? Okay, so why don't we take a look at the solar telescope here? We're getting close to countdown here. We are about 5 or 6 minutes out from our moment of solstice. So we're getting 2 solstice times. So we're going to snap some photos for both of them at the 1451 UTC and 1457. The date of the solstice also changes. It's not always the 21st. There is a fluctuation sometimes of a day or two, but the highest point of the sun in the sky, at least for those of us in the northern hemisphere, is the actual date of the solstice when we are closest to the sun. So Mac or Jenny, again, we're seeing some of these filaments on the surface of the sun. This looks like a plage to me, these bright areas with an active region, that dark spot. So I think I'll take a picture here.
Look at that long
Also
filament
got the
where you're
settings.
pointing.
Yeah, this S shape. Yeah. Could be a filament. It could also be a hair stuck to the
It's a real
camera
film.
of the solar telescope.
How
Probably
dare
not.
you,
That's a
Keith,
joke. That's a running.
It's
That's a running joke that we have here.
yes,
suggesting
right.
that the solar
It tends to
telescope.
rotate.
It's nothing
with
that a
the sun.
bulb blower can't fix.
Unfortunately, that one's not fixable
So, Paul,
remotely.
listen to what you've got here before we get to
Say again, Keith, I didn't pick that up.
Paul, so fill us in on what we've got here. We are approaching the moment of solstice. I'm looking at my phone here. I've got 10:46. We have 10:51. So we're 5 minutes out from the moment of solstice. Just fill us in on your final thoughts here on the sun before we.
Well, only that, we've been absolutely treated to some spectacular views, haven't we, over the last few days? I've actually been in control of the scope for a few days now. And one of the things I love best, we'll go back to it, maybe after the moment, is when we see these huge prominences on the left-hand side, as Max said, the east side, that's where the features are rotating into view. So when we see that enormous prominence, we know that in a couple of days' time, we are going to be in for one heck of a treat, because that is all rooted in a huge active region. And as the sun spins on its axis, that's going to slowly come into view. One of the other interesting things here is you'd expect solar features to kind of travel horizontally across the sun, left to right. But because of our apparent tilt to the sun, we see them going slightly diagonally across. So actually, when we look up now, north, celestial north is directly up there. So
Yeah, great work.
quick vote, Keith, on which view people would like to celebrate the moment. Do you want this view, or would you like the prominence view? There you go.
We don't have a poll here function, but if you want to put it in chat, I think it's just been great work with the solar telescope, and the sun has been putting on such a show. It's really been mind-blowing. I'm not a huge solar observer, but even I get excited with some of the observations that we see on the Slooh page. Chat is open, so Paul is here. Let him know what you want to see for your solstice image, your live
I
shot.
personally prefer this view, but I cannot deny that the other one is impressive because it shows all the solar activity.
I think I go with you, Milton.
I'll vote for that. I think Milton's right. I like seeing all of those other ones. It is a toss-up though. They're both fantastic. Anyone else? You can add it into the chat what your preferred view is. I'm thinking everyone's like every view is fantastic. So you choose.
One of the things, Keith, can I just jump in? One of the really interesting things talking about today is solstice. Down in the bottom left-hand corner of the solar telescope, you can see that's the internal dome cam. So we're looking across the dome, and you see that V shape where we can see some blue sky behind it. Well, because this is June solstice, we only have to open the north shutter of the dome to get the view of a clear, unobstructed view of the sun. So during December solstice, it's only the southern shutter that we have to open. And this is, of course, because, as you said right at the beginning, the sun is at its most northerly in our sky on June solstice. So just thought I'd add that.
So we're about 2 minutes away from our
The first listed
time of the event. Again, first listed time. We're going to do it again at 10:57, which I think is 14:57 UTC. for the solstice event. And once again, this is a time-specific event, like the full moon. We think of the full moon as being, all night. It isn't. There's an actual moment of full moon, like an eclipse, right? The moment of totality does change during an eclipse, but it will vary depending on how things are positioned. It can be anywhere from a minute to 7 minutes, but the moment of totality is specific regardless of how long it is. So we're getting very close here. We're 10:50. I don't know, Gretchen, we don't have a countdown clock to get us to the moment. I don't have my seconds clock. I should have done this, but we're almost at the moment of our summer solstice, official beginning of summer, the highest point of the sun in the sky for us in the northern hemisphere, the southern hemisphere, the beginning of winter for us, the beginning of summer.
Well, take your snaps now.
10:51, fire away, take your shots. I'm going to take a few.
Take a picture. So hopefully you guys have a split screen up. You've got the webinar, and then you also have Slooh loaded, and then a tab on the solar scope, which is showing it is not disappointing today. So that's awesome.
So for those who really want to get fancy with this, we can make a composite image so you have the entire sun in the field of view. You do that by stitching it together, and we can combine all that data knowing that this lower portion is the image from the moment of solstice. So we'll have another solstice at 10:57. Did everybody get a shot? Let's take a look and go back to this diagram and look at exactly what's happening at this moment. So I was talking about this. It's the longest day. It's the most sunlight that we're going to have in the northern hemisphere. The sun is right at the top, the highest point of the sky. Where Milton is, it's the exact opposite. It's still the highest point, but it's very low. So Milton, I would imagine that if you have trees or buildings in the background, you're seeing the sun not even clearing them, it's just passing through the trees or the buildings or wherever you happen to be.
That's right. Also, for example, one of the biggest cities is a valley. So, the sun has trouble climbing over the mountains.
Yeah, and that's got to be, kind of disconcerting, And as I said, if you're in Antarctica, you don't even really see the sun. It's very, very low on the horizon. But for those in the Arctic Circle, the sun never really sets. And I've run some projections in Stellarium. Very interesting to watch the way the sun just barely dips beneath the horizon. I didn't run a simulation in Antarctica, but maybe I'll do that later and share that with some of our campers later today. We didn't really talk a lot about that. So let's go back to the solar scope, 10:53. This is our second solstice shot, depending on whose timekeeping you use. We're going to get the top half. So again, this is where we can stitch together our sun images to get the entire sun in the field of view. Again, we have that prominence. So this filament, before the sun turned to make it a filament, was a prominence on the limb. Mac, do you recall which one this was? Do you have an image of this as a prominence that we can compare to?
No, actually, well, I'd have to go back and look, but I thought the prominence was related to this filament until they separated. So we've actually got, as you said earlier, another active region following behind the filament.
I did,
and
yeah, over here,
exactly the same. No, that this S filament that Mac was talking about was exactly what I thought this morning when we first saw the view. It looked like it was going all the way to the limb of the sun and was associated to those huge prominences. Is that what you thought, Mike?
I had thought that, but it turned out not to be. It's a separate phenomenon, separate prominence. So again, filaments are prominence facing us, so that they appear darker than the surrounding photosphere or chromosphere, and that's because the plasma that makes up a filament is elevated above the surface enough to cool it relative to the hotter sub layers underneath, so it looks dark compared to the photosphere, which is the brightest part of the sun's surface. It's just a contrast, optical illusion, as it were.
Yeah, and it's also based on, again, our position relative to the sun. As the sun turns, it's still there. It's just we're looking at it face on instead of, edge on the limb of the sun. So we're at 10:55. 2 more minutes, depending on how you keep time for the solstice event. We'll get our second image here. Gretchen, do you have anything to add here? What's up and coming on your schedule in terms of events?
I'm so glad you asked. So we have kicked off astronomy camp, and that is for Slooh student members. It's in the afternoon. Check out the Slooh page where you can sign up. You can still sign up. You can even join us today at 2 o'clock Pacific time. So that is happening. And then of course we have our Tuesday show where you guys can join us Tuesdays night, 8 p.m. Eastern Daylight Time on Zoom, where we talk about everything in the sky. Mac and Jenny are there giving us an update on the sun, and it's just a lot of fun to learn more about what's going on and how to find awesome objects using scopes. So yeah, good stuff.
Okay, so we're a minute away. The Tuesday show has moved over to Zoom, so you do have to register for that. It's a little different than Discord. That was kind of unanimous. Zoom gives okay, 10:57. So let's get our second photograph of the solstice event, depending on how you keep time. I was seeing different times. So we've got that. Yeah, so you do have to register for the Zoom events, but I like it because Zoom gives us certain functions and functionality that we don't get in Discord. Screen sharing is easier, just everything is kind of easier with Zoom. So let's get back here. These are, I'll take one more picture. So depending on how you keep time, we can have images here of the solstice in both times. Milton, how about you?
I'm receiving the energy of
Okay,
your sun.
You're imaging, yeah. Hold that up. That's the person with looking at the monument. Okay, I get it.
Yeah, now
I hope all that energy of the sun accompanies all of us throughout this next lunar year, and gives you all the energy we need to continue inspiring people to look up and wonder.
Oh, that's beautiful. I love that. And that is the reminder when we talk about the solstice and the sun standing still, and a moment for us to actually stand still and sort of be present and be in that moment, right? And that's why it was so special way, way, way back when they built these structures that you talk about, right? And to remind us and to be in that and to bathe in the sunlight. So that's like super cool. I love that. Wow, we are getting now another fantastic view with these, I like to call them dancing prominences, right? So Milton, was there more that you had to finish up or add to what you were sharing with us about the solstice lore, is what I like to call it?
Well, the most important thing, I guess, is to understand that people in the past were more connected to their surroundings by observation, something that we may have lost because we're looking now down at our cell phone screens or computer screens. But over there, with the absence of those elements, people were more aware of their surroundings, and I think that's what made all these celestial objects, the sun, the moon, the planets that are observable with the naked eye, moments of wonder for ancient people, to the point that they dedicated whole structures to that observation. So you can see what a change of pace this means, right? So I think what I would like to add is only that I feel fortunate to share this moment with people who are aware of their surroundings despite all this technology, because we understand the processes, we understand how the universe works, and that is valuable. And I hope that more people join us so that they can also understand, the universe around us, because we're part of it anyway.
I think that with that being said, those are perfect words to end our show on the solstice. But without leaving it, we have to say hello to Carol. I know that it looks like you're actually able to speak to us today. So if you can unmute it and follow kind words like Milton shared with us, I think we'll call it a day.
I think Milton hit the nail. I can't really add to that. Being of an older generation and starting off my stargazing without all this technology, I actually some days wish we could just turn back the clock and go back to those days. But then we wouldn't have been able to watch the solstice on Slooh if it weren't for technology. So we've got to balance all of this. But it's nice to see all your faces, and I've really enjoyed this show. And today, this new laptop of mine has realized what it's in for. I've been snapping away so many pictures, but it's been nice to see you all. It was a wonderful show. Thanks.
You're so welcome, Carol. It's really great to see your face and to have everybody join us, and all those who are watching on the Slooh page and the replay. And thank you, Paul Cox, for jumping in, for manning the scope today and sharing some fantastic views. The scope is still up, you guys, so when we're done here, you can hop on over there. You can even jump on Discord and get a running commentary from Jenny and Mac, who also I thank for being here today. Milton, for sharing your solstice lore, and Keith, of course, for all of the science and knowledge and wisdom that you brought to the table. So you guys, happy solstice. Have a fantastic and beautiful day, and thanks for being here.